Hello everyone. Today we will be doing the topic of collision. In the next 1 hour, you will be able to understand everything about collision and the type of questions that can come in your NEET examination. So without wasting time, first of all, understand the process of collision. So when I say collision, what is collision? If two bodies tries to occupy the same space at the same time, collision is bound to happen. So we say collision takes place when two bodies tries to occupy the same space simultaneously. So two bodies tries to occupy the same space simultaneously, then collision takes place. Now, what I'm trying to explain next is the most important thing that one must know in collision. So these are called the steps of collision. When a collision takes place, first the bodies come into contact, then the bodies deform, then the bodies reform, and then the bodies separate. So first the bodies come into contact, then the bodies deform, then the bodies reform, and then the bodies separate. So what are the steps of collision? First, the bodies get into contact. Once the bodies get into contact, they start applying force on each other. And then the force keeps on increasing, the deformation keeps on increasing. There comes a time which is called the time of maximum deformation. There are two things a child must know about the time of maximum deformation. First, at the time of maximum deformation, the interaction force between both the bodies is maximum. Second, at the time of maximum deformation, both the bodies have same velocity along the line of impact. So what is the line of impact? The line along which the forces act during the collision is called the line of impact. So, first the bodies get into contact, then they start deforming, and at the time of maximum deformation, you have to remember two things. The first thing is that at the time of maximum deformation, both the bodies have same velocity along the line of impact, and second, at the time of maximum deformation, the force acting between the bodies is maximum. Then the bodies start to reform, the force decreases, and then the bodies separate. So, first is getting into contact, second is reaching the state of maximum deformation. And you should know this about maximum deformation. At the time of maximum deformation, both the bodies have same velocity along the line of impact. This is an important thing. Once the bodies have reached the state of maximum deformation, then the bodies reform and then the bodies separate. So these are the four steps which I say exist in collision. Now let's see a question, a simple question based on the concept we have learned till now. Let's say there are two blocks, a block of mass 4 kg moving towards right with a speed of 3 meter per second and another block of mass 1 kg moving towards left with a speed of 2 meter per second. Question is, determine the speed of the blocks at the time of maximum deformation. What will be the common speed of both the blocks at the time of maximum deformation? So we can say at the time of maximum deformation, both the bodies have common velocity along the line of impact. Line of impact is the line along which the forces act during the collision. So let's say this is our line of impact, the horizontal line. Along this horizontal line, the forces will act during the collision. So let's say both the bodies have a common velocity v at the time of maximum deformation. So we can visualize that both the bodies 4 kg and 1 kg will have that common velocity v at the time of maximum deformation. To find this common velocity v, we can apply the principle of conservation of momentum on the 4 kg 1 kg system. We can apply the principle of conservation of momentum on the 4 kg 1 kg system. So from momentum conservation, we can say initial momentum of the system equals to final momentum of the system. I have taken the direction towards right as positive. Initial momentum of the system will be written as 4 into plus 3 plus 1 into minus 2 because I have taken direction towards right as positive. So the velocity towards left and the momentum towards left will be taken as negative. So initial momentum equals to final momentum. That will be 4 plus 1 into v. So the common velocity at the time of maximum deformation will be how much? So 12 minus 2, 10 equals to 5 into v, or v comes out to be 2 meter per second. So this will be the common velocity at the time of maximum deformation. Moving on, some important terminology that you should know. First, what is line of impact? Line of impact is the line along which forces act during the collision. For example, let's say in a gravity-free region, a ball is projected towards the ground. When the ball goes and hits the ground, at that instant, in which direction the forces will act between the ball and the ground? So you will say, sir, the forces will act along the normal. So this vertical line will be the line of impact, the line along which forces act during the collision. And for example, if we have got these two bodies, let's say you are playing carom and here are the two pieces on the board which are colliding. If this arrows represent the velocity, what will be the line of impact? In which direction force will be applied by one of the coin on the carom board on the other? So you will say, sir, the line of impact will be nothing but the common normal. So this line will be the line of impact. So once again, what is the line of impact? The line along which the forces act during the collision. That's called the line of impact. The next term you should know is impulse of deformation. So what is impulse? Change in momentum. When the bodies come into contact, after that the bodies deform. As the bodies deform, they apply force on each other. So the force applied by bodies on each other is equal and opposite. So the change in momentum of both the bodies is equal and opposite. The change in momentum of the bodies is the impulse. Now, the change in momentum taking place during the process of deformation is called impulse of deformation, and the change in momentum of the bodies taking place during the process of reformation is called the impulse of reformation. So, what is impulse of deformation? Magnitude of change in momentum of the body during deformation is called impulse of deformation. Similarly, we have a term called impulse of reformation. The magnitude of change in momentum during the process of reformation. So first the bodies get into contact, then they deform, then they reform, then they separate. So the change in momentum during the process of deformation is called impulse of deformation. Now many a time students ask me, sir, impulse of deformation of which body? The first body or the second body? Beta, the change in momentum of both the bodies will be equal and opposite. So when I say impulse of deformation, just to find the change in momentum of any one of the body during the process of deformation. Both the bodies will have equal and opposite change in momentum. Similarly, impulse of reformation is the change in momentum from the maximum deformed state till the time the bodies separate. So here is the next terminology that you should know: impulse of deformation, impulse of reformation. The other terminologies which you must know is what is velocity of approach and what is the velocity of separation. It is obvious that two bodies approach each other before the collision and they separate out from each other after the collision. Two bodies approach each other before the collision and they separate out from each other after the collision. So what is the velocity of approach? The rate at which separation decreases along the line of impact before the collision is called velocity of approach. The rate at which the separation decreases along the line of impact before the collision is called velocity of approach. Definitely the bodies approach each other before the collision and they move away from each other after the collision. So what is the velocity of separation? The rate at which the separation increases along the line of impact after the collision. So before collision, the bodies approach each other. After collision, they separate out from each other. So velocity of approach is the velocity at which they approach each other before the collision, and velocity of separation is the velocity at which they separate out after the collision. So now we will talk about a super duper important term called the coefficient of restitution. The symbol used for this term, coefficient of restitution, is E. E is defined as velocity of separation upon velocity of approach, the rate at which the separation increases after the collision upon the rate at which the separation was decreasing before the collision. That is the velocity of approach. Now remember that you must take velocity of separation and velocity of approach along the line of impact. But the true definition is coefficient of restitution is impulse of reformation upon the impulse of deformation. that is the change in momentum during the process of reformation after reaching the max deformed state upon the change in momentum of the body during the process of getting into contact till the time of maximum deformation. The definition which we are going to use to solve question is velocity of separation upon velocity of approach, but this is the true definition of coefficient of restitution. Now, moving on. Coefficient of restitution is 0 for perfectly inelastic collision. What is the meaning of perfectly inelastic collision? Look at both the definitions. When I say that coefficient of restitution is velocity of separation upon velocity of approach. If I say that coefficient of restitution is 0, it means that velocity of separation upon velocity of approach is 0. This means that velocity of separation has to be 0. This means that after the collision, the bodies do not separate from each other. They have the same velocity along the line of impact just after the collision. This is the meaning of having coefficient of restitution 0. Both the bodies have same velocity along the line of impact after the collision. That's why after the collision, the separation between them do not increase and velocity of separation is 0. We can even look from the second definition. E equals to impulse of reformation upon impulse of deformation. When I say that for a perfectly inelastic collision, coefficient of restitution is 0, it means that beta the impulse of reformation has to be 0. And when I say that impulse of reformation is 0, this means that the bodies do not reform after reaching the max deformed state. So the bodies get into contact, then they deform. But if E is 0, the bodies are not at all reforming. So these type of collisions are shown by perfectly plastic bodies which do not try to regain their original shape. So remember that E equals to 0, perfectly inelastic collision. In such a collision, since the bodies do not reform, there is maximum loss of energy in these type of collisions. Now let's talk about the general collisions which take place in everyday life. For general collisions taking place in everyday life, the coefficient of restitution lies anywhere between 0 and 1. Such collisions are called inelastic collision. In case of inelastic collision, some energy is lost. Definitely, if the value of coefficient of restitution is between 0 and 1, this means that this number E is less than 1. If the number E is less than 1, it means that impulse of reformation is less than the impulse of deformation. Or you can say if E is less than 1, then the velocity of separation is less than the velocity of approach. This is the meaning of inelastic collision which takes place in everyday life in most of the collisions. Now the last one, coefficient of restitution equals to 1. We say that the coefficient of restitution is 1 for perfectly elastic collision. For a perfectly elastic collision, if I substitute E equals to 1, then you can say impulse of reformation is equal to impulse of deformation. So the change in momentum during the process of deformation is same as the change in momentum during the process of reformation. Or velocity of separation will be equal to the velocity of approach in case of elastic collisions. Okay. Now, bacho, let's say here we have got two bodies. The body behind moves with speed u, the body in front moves with speed v. How will you write the velocity of separation and how will you write the velocity of approach? So you will say, okay, if you ask me what is the velocity of separation, this means that you are asking me the rate of increase of separation after the collision. So if you are asking me what is the velocity of separation, you are asking me at what rate the separation increases after the collision, right? If the separation between these two bodies is increasing, what has to be the correlation between u and v? So sir, if the separation between these two bodies is increasing, then v has to be greater than u. Now I am asking you, what is the velocity of separation? What is the rate at which the separation between them is increasing? Notice that the velocity of the ball in front, which has got velocity v, is trying to increase the separation. The velocity of the ball behind, which has got velocity u, is trying to decrease the separation. So if the separation increases, the velocity of separation will be v minus u. This velocity v is trying to increase the separation. The velocity u is trying to decrease the separation. So you will write velocity of separation will be v minus u. Okay. Now for the same picture, I said that tell me what is the velocity of approach. So you will say, okay, you are asking me velocity of approach. It means that collision is going to happen. Velocity of approach is the rate of decrease of separation before the collision. So you are saying, okay, you are asking me velocity of approach. If these two bodies are approaching each other, then I can say with 100% guarantee u has to be greater than v. If I say that u has to be greater than v, what will be the velocity of approach? You will say, sir, the velocity u is trying to decrease the separation, while the velocity v is trying to increase the separation. So when I write the velocity of approach, how will I write it? So sir, u is trying to decrease the separation, that is trying to make them approach, while v is trying to increase the separation, that is trying to make them go away. So the velocity of approach will be plus u minus v. So velocity of approach will be u minus v. So for this particular case, you can say that velocity of approach will be u minus v. The next case, in this case you have got no doubt. You will say just by looking at the direction of velocities, I can say that both the bodies are approaching each other. So this must be the picture before collision. And if this is the picture before collision, what will you write the velocity of approach as? So you will say, sir, since both the bodies are approaching each other, the velocity of approach, both the velocities are trying to decrease the separation. So I will write the velocity of approach as plus u plus v, since both the velocities are trying to decrease the separation. Next, again the same picture as the first time, but this time you need to tell me what is the velocity of separation. If this is what the velocities look like after the collision, then what is the velocity of separation? So you will say, okay, I need to find the velocity of separation. That is the rate at which the separation between the bodies increases after the collision. So you will say the velocity of separation. The velocity v is trying to increase the separation. The velocity u is trying to decrease the separation. If the velocity v tries to increase the separation while velocity u tries to decrease the separation, the velocity of separation will be plus v minus u. So velocity of separation, bachcho, here will be v minus u. And the last case, just by looking at the direction of velocities, you can say, okay, both the bodies are moving away from each other. So both the velocities are trying to increase the separation. So we will write the velocity of separation to be plus u and plus v. So now practice out some question to understand how to use the equation E equals to velocity of separation upon velocity of approach. The first question, simple question. There is a block of mass 2 kg going towards right with a speed of 8 meter per second. It goes and collides with the wall. For this particular collision, the coefficient of restitution is 0.5. The simple question, determine the velocity of block after the collision. So this is common sense that after collision, the block will move towards left. Let's say after collision, the block goes towards left with some speed v. We know that coefficient of restitution is velocity of separation upon velocity of approach. Velocity of separation is the rate of increase of separation after the collision. Velocity of approach is the rate of decrease of separation before the collision. So if I ask you kids, tell me what is the velocity of separation? What is v? How will you find? You will say, sir, easy. Wall is fixed. Before collision, the block moves towards the wall with a speed of 8 meter per second. So I can say for sure velocity of approach, the rate at which the separation decreases before the collision is 8 meter per second. Now, after collision, I have assumed that the block goes away with a speed v. The wall is again fixed and the block goes away with a speed v. So the velocity of separation will be equals to v. So coefficient of restitution 0.5 equals to velocity of separation upon velocity of approach. Velocity of separation will be v. Velocity of approach is 8. So v will be nothing but 0.5 into 8. That comes out to be 4 meter per second. Similarly, let's try out the next question. Question is, there are two blocks, one of mass 4 kg, another block of mass 2 kg. The block of mass 4 kg goes towards right with a speed of 8 meter per second. The block of mass 2 kg goes towards left with a speed of 4 meter per second, and the coefficient of restitution is 0.75. 0.75 means 3 by 4. Question is, determine the separation at time equals to 5 seconds after the collision. What will be the separation between both the blocks at time equals to 5 seconds after the collision? So sir, at the time of collision, separation will be zero now. At the time of collision, both the blocks will be at same place. So separation will be zero. My question is, what will be the separation between them at time equals to 5 seconds after the collision? So you will say, we know that coefficient of restitution E equals to velocity of separation upon velocity of approach. Here I can easily tell what is the velocity of approach. Both the velocities of 8 meter per second and 4 meter per second are try to make the blocks approach. So I can say velocity of separation, the rate at which the separation increases after the collision, equals to coefficient of restitution times velocity of approach. So 0.75 E equals to velocity of separation upon velocity of approach, which is 8 plus 4, 12. Hence we will get the velocity of separation to be equals to 0.75 into 12. 12 times 0.75, in place of 0.75 you can write 3 by 4, so you get 12 times of 3 by 4, that comes out to be 9 meter per second. When I say that velocity of separation is 9 meter per second, what is the meaning of it? Sir, after collision, the separation between the blocks increases at the rate of 9 meter per second. So every second, the separation between the blocks will increase by 9 meter. So in 5 seconds, how much will the separation increase? So sir, in 5 seconds, the separation will increase by 45 meter. So at time equals to 5 seconds, separation will be 9 into 5, that will be equals to 45 meter. So let's see the next example. So now let's do a fun question. Question goes like, a ring of radius r is placed on a table. So ring is placed on a table. Determine the time gap between the first and second collision. So there is a tube placed on a horizontal table. Within this tube, on the two diametrically opposite ends, we have got two particles. One of the particle is at rest, while other particle has been given a velocity v. Question is, determine the time gap between the first and second collision. So after making the first collision, after how long they will again collide. So let's visualize the picture just before the first collision and just after the first collision. So just before the first collision, this particle, let's call it A, will be at rest. While the second particle would have reached there, they are moving on the horizontal table. And this will be just about to hit with a speed v. So let's call this second particle v. And after collision, they both will move away from each other. Let's say with some velocity v1 and v2. Now, if I ask you what is the velocity of approach? So sir, just before collision, this first particle is at rest, the second one is going to come and hit with a speed v. So I can say that the velocity of approach equals to v. What will be the velocity of separation? So you will say, sir, velocity of separation will be equal to, both of them have got velocity in opposite direction. After the collision, both the velocities are trying to increase the separation. So just after collision, velocity of separation will be v1 plus v2, right? So keep these things in mind. Velocity of approach will be v, while velocity of separation will be v1 plus v2. Now, bachcho, we know that coefficient of restitution equals to velocity of separation upon velocity of approach. Velocity of separation will be written as v1 plus v2, both of them having velocity in opposite direction, upon the velocity of approach, which is simply v. So we can say that E equals to velocity of separation by v, or beta velocity of separation is EV. Now why this particular thing is important? The mission is to determine the time gap between the first and second collision. After how long the second collision will take place. Let's say the second collision takes place after a time t. So in a time t, this first ball, which is now moving with a speed v1, would have traveled a distance v1t, while the second ball would have moved a distance v2t. And we can say that v1t plus v2t, the sum of distance traveled by both of them has to be equal to perimeter of this tube, has to be equal to 2 pi r. So the time gap between the first and second collision will be 2 pi r by v1 plus v2, which can be written as 2 pi r by velocity of separation, because v1 plus v2 is velocity of separation. So the time gap between two consecutive collision will be 2 pi r by velocity of separation. So we can say time gap between the first collision and second collision will be 2 pi r by the velocity of separation, and in place of velocity of separation you can write EV. So you get simply 2 pi r by EV. Let's see the next thing. Now the question is, there are two blocks of mass 4 kg and 1 kg. The block of mass 4 kg moves towards right with a speed of 3 meter per second, while the block of 1 kg moves towards left with a speed of 2 meter per second. Coefficient of restitution is 0.5. Question is, find the velocity of both the blocks after the collision. So let's say, hypothetically, both the blocks move with velocity u and v after the collision. Our mission is to find velocity of both the blocks after the collision. Our mission is to find u, our mission is to find v. Better do not waste iota time in assuming in which direction I should take the final velocity. Take in whichever direction you like. If I have assumed that the 4 kg block has got a velocity towards right after the collision, and if it is actually towards left, I will get a negative answer. Again saying, without wasting any time, assume the velocities in any direction. If you have chosen the right direction, you will get positive answer. And if you have chosen the opposite direction, the wrong direction, you will get a negative answer. That's what you will mean if I get a negative value of u. It means that after collision, the block of mass 4 kg moves towards left. Now, how to find u and v? To find u and v, we can make two equations. The first equation is the equation of conservation of momentum. So we say from momentum conservation, for the system of 4 kg and 1 kg block, since during collision 4 kg block applies force on 1 kg block, 1 kg applies force on 4 kg block, but there is no external force on both of them. Hence, the momentum of the system will be conserved. So we can say initial momentum of the system 4 into 3 plus 1 into minus 2 equals to final momentum of the system, which is 4 into u plus 1 into v. So we can write equation 4 into 3 plus 1 into minus 2 equals to 4 into u plus 1 into v. Now beta 4 into 3, 12 minus 2, 10, 10 equals to 4u plus v. So you get 10 equals to 4u plus v. This is the equation from momentum conservation. We can make one more equation, and that will be the equation of coefficient of restitution. We know that the coefficient of restitution will be velocity of separation upon velocity of approach. So from coefficient of restitution, E equals to velocity of separation upon velocity of approach. Now beta, for this case, how will you write the velocity of separation? You will say, sir, this velocity v is trying to increase the separation, while this velocity u is trying to decrease the separation. So the velocity of separation will be plus v minus u upon the velocity of approach. Both the blocks are trying to approach each other with velocity of 3 meter per second and 2 meter per second before the collision. So velocity of approach will be equals to 5 meter per second. So coefficient of restitution equals to velocity of separation upon velocity of approach. So 0.5, which is the coefficient of restitution, equals to v minus u by velocity of approach, which is 5. Now if you bring this 5 up and multiply, you will get v minus u equals to 5 into 0.5. 5 into 0.5 is 2.5. So here we have got two equations and two variables. How to solve? Beta, multiply each term of the second equation with 4 and add. How? Let's see. You can write the first equation as 4u plus v equals to 10. I have just swapped the left and right hand side. Okay, 4u plus v equals to 10. And in the second equation, multiply each term with 4. Why I am doing this? Just wait and see. So I will write 4v minus 4u equals to 2.5 into 4, which is 10. So I get 4v minus 4u equals to 10. Now beta, when I add both the equations up now, this 4u and 4u get cancelled. So I get 5v equals to 20, and if 5v equals to 20, then v has to be equals to 4 meter per second. Once I have found out the value of v, it is very easy to find out u. Simply substitute beta v here. So you will get 4 minus u equals to 2.5, hence u will be equals to 1.5. Now since I have got both u as well as v as positive, it means that the direction which I chose is right. Otherwise I would have got a negative answer. So the block of mass 4 kg will keep on moving towards right with a speed of 1.5 meter per second, and the block of mass 1 kg will also move towards right with a velocity of 4 meter per second. Okay, let's practice another question of same type. So the question goes like, there are two blocks of mass 6 kg and 4 kg. The block of mass 6 kg has velocity 8 meter per second towards right, and the block of mass 4 kg has velocity 3 meter per second towards right. The coefficient of restitution is 0.5. Question is determine the velocity of both the blocks after the collision. So again, assume that both the blocks have some velocity u and v towards right after the collision. Again, I am saying if you have assumed the wrong direction, you will get a negative answer. Do not waste your time thinking that in which direction I should take, towards right, towards left. Just assume and start solving. So you can say again, sir, we can make two equations. First, the equation of conservation of momentum. So if I take the direction towards right as positive and make the equation of conservation of momentum, I will say from momentum conservation, the initial momentum of the 6 kg and 4 kg block system will be equal to final momentum of 6 kg and 4 kg block system because there is no external force acting on it. So we will say 6 into 8 plus 4 into 3, the initial momentum has to be equals to 6 into u plus 4 into v. So 6 into 8, 48, 4 into 3, 12, 48 plus 12, you will get 60. So you will get 60 equals to 6u plus 4v. Or you can resolve it a little further and write 3u plus 2v equals to 30. I have just divided each term by 2 and move the right hand side to the left hand side and left hand side to the right hand side and divided each term by 2. This is the first equation. I got this equation from momentum conservation. Now let's make one more equation, and this equation will be equation of coefficient of restitution. We will say that coefficient of restitution E equals to velocity of separation upon velocity of approach. Now here, after collision, how will you write the velocity of separation? Again, the velocity V is trying to increase the separation. The velocity U is trying to decrease the separation. So the velocity of separation will be V minus U, while the velocity of approach, this velocity of 3 meter per second is trying to increase the separation, while the velocity of 8 meter per second is trying to decrease the separation. So the velocity of approach will be plus 8 minus 3, that will be 5. So you will write E equals to velocity of separation upon velocity of approach. So that will be equals to 0.5 E equals to velocity of separation V minus U upon velocity of approach, which is 5. So on multiplying 5 on the left hand side, you will get V minus U equals to 5 into 0.5, that will be 2.5. Now again we have got two equations. The first equation 3u plus 2v equals to 30. The second equation v minus u equals to 2.5. Again I will multiply this time the second equation with a factor of 3. And we can rewrite the first equation as 3u plus 2v equals to 30. And on multiplying the second equations each term with 3, I will get 3v minus 3u equals to 2.5 into 3, and 2.5 into 3 is 7.5. So beta, when we add them up now, again this 3u minus 3u get cancelled. So on the left hand side, I will get 3v plus 2v, 5v equals to 30 plus 7.5, that is 37.5. And beta, 37.5 divided by 5 will be 7.5. 37.5 divided by 5 will be 7.5. So v will be equals to 7.5 meter per second. Once we know the value of v is 7.5 meter per second, resubstituting it back here, we can find out the value of u. So we will write u will be 7.5 minus u equals to 2.5. So u has to be equals to 5 meter per second. Easy. Let's try the next example. Question is, a mass m moving with a speed v collides head on with another mass 2m at rest. So mass m moving with speed v collides head on with another mass 2m at rest and comes to rest. So the mass m after collision comes to rest. Determine the coefficient of restitution. So you can visualize the picture. Initially the mass m is going with a speed v and the mass 2m was at rest. After collision, the mass m is at rest and the mass 2m moves. So visualize the final condition as well. Now let's say we have assumed that the mass 2m moves with a speed v dash after the collision. They haven't given me v dash, but they are asking me what is the coefficient of restitution. What to do? Sir, we know that coefficient of restitution equals to velocity of separation upon velocity of approach. Initially this mass 2m is at rest and another mass m is approaching with speed v. So sir, velocity of approach has to be equals to v. Now how to write the velocity of separation? Sir, after collision, the mass m comes to rest. and the mass 2m moves with the speed v dash, we have assumed. So we will say the velocity of separation after the collision will be v dash. Now from momentum conservation we can find out v dash, and once we know v dash and v, we can get the value of E. So we will say from momentum conservation, initial momentum of system mv equals to final momentum of system, that is 2mv dash. Since mv equals to 2mv dash, we know that v dash will be equals to v by 2. Now we know the velocity of approach and velocity of separation. Velocity of approach will be v. Velocity of separation will be v dash. So we know that coefficient of restitution will be equals to velocity of separation upon velocity of approach. So that will be equals to velocity of separation upon velocity of approach, that will be v by 2 by v, that will be equals to half. So from doing momentum conservation, we found out the velocity of separation. Once we know it, we used it to find the coefficient of restitution. Easy question. Let's see one more example before learning a little more theory. So question, there are two blocks of mass 2m and m. They are moving with velocity 2v and v, and the coefficient of restitution is 0. When the coefficient of restitution is 0, velocity of separation is 0. It means that both the bodies move with the same common velocity after the collision. They have the same common velocity along the line of impact. So question is, determine the loss in energy due to collision. We have learned that in the case of perfectly inelastic collision, where E is 0, we get maximum energy loss during the collision. So if they collide perfectly inelastically, they will have a common velocity after the collision because the velocity of separation will be 0. So as E equals to velocity of separation upon velocity of approach, and as E is equals to 0, we can say that the velocity of separation is 0. And once we say that velocity of separation is 0, we can say that so both the bodies have the same velocity along the line of impact after the collision. Now let's say this particular velocity has been assumed to be v dash. So after collision, both the bodies will have same velocity along the line of impact because the velocity of separation is 0. The separation between them doesn't increase after the collision. If the separation between them is not at all changing, they are moving with the same velocity, say v dash. Now beta, from momentum conservation we can find out this v dash. How? We will say on the 2m and m system there is no external force acting, so the momentum of 2m and m system will be conserved. So we will say from momentum conservation, 2m into 2v, 2m into 2v plus m into minus v, 2m into 2v plus m into minus v. Initial momentum should be equals to 2m plus m into v dash, that is 3m into v dash. So on the left hand side you get 4mv minus mv, 3mv, and on the right hand side you get 3mv dash. So beta, on cancelling them you get v dash equals to v. So the final common velocity in this particular case, since it is perfectly inelastic collision, is v. Our mission is to find the loss of energy. You will say, sir, loss of energy, we can find the initial kinetic energy of system, we can find the final kinetic energy of system, and we can subtract them. Once we subtract them, we will get what is the loss in energy. So loss in energy equals to kinetic energy initial minus kinetic energy final. You will write the kinetic energy initial as half into 2m into 2v square plus half into m into v square. This whole will be the initial kinetic energy. And what about the final kinetic energy? Half into 3m into v dash square. And as v dash equals to v, we can even say half into 3m into v square. So we will get initial kinetic energy of system half into 2m into 2v square plus half into m into v square. This whole term is the initial kinetic energy of system minus the final kinetic energy of system, which is half into 3m into v square. So beta, once we solve this out, we can get the loss in kinetic energy is half mv square into 6, or that becomes equals to 3mv square. So I think till here is the important part. After that you can do the calculation easily. So now let's solve out one more question. For elastic collision of two particles, momentum and energy both are conserved. Elastic collision means beta E equals to 1. Momentum and energy both are conserved. Only momentum is conserved. Momentum and kinetic energy is conserved. Only kinetic energy is conserved. Which of them is the right option? For an elastic collision, we say that no energy loss. Yes, if E equals to 1, there is no energy loss. So we can say kinetic energy after the collision, kinetic energy final equals to kinetic energy before the collision, kinetic energy initial. So if the collision is elastic, E equals to 1, then the kinetic energy of the system after the collision is same as kinetic energy of the system before the collision. Yes, but you should remember kinetic energy is not conserved in elastic collision. Why? Because in an elastic collision, the bodies get into contact, yes, and then they deform. So some part of the kinetic energy before the collision gets converted into elastic potential energy. In case of elastic collision, impulse of reformation is equal to impulse of deformation. E is 1. So impulse of reformation is equal to impulse of deformation. So the bodies completely reform. So first the bodies come into contact. Some part of their kinetic energy gets converted into elastic potential energy. Then they reform. The elastic potential energy again gets converted into kinetic energy and then they separate. In case of perfectly elastic collision, the kinetic energy after the collision is same as kinetic energy before the collision. But during the collision, some part of the kinetic energy gets converted into elastic potential energy. That's why for the whole collision process, we can't say that kinetic energy is conserved. So beta, remember that kinetic energy is not conserved. This statement is wrong. Now, if no external force acting on the system, we can say that momentum is conserved. And in case of elastic collision, energy is conserved. That's why the correct option has to be option number 1. So in an elastic collision, the momentum is conserved given that there is no external force acting. That is a rider I'm assuming on this question. Second, the kinetic energy after collision is same as the kinetic energy before collision in case of elastic collision. Total energy is conserved during collision because kinetic energy gets converted into elastic potential energy during the process of deformation, and then elastic potential energy gets converted into kinetic energy during the process of reformation. But kinetic energy is not conserved during the entire process, but kinetic energy is not conserved. Okay, remember this. Now let's understand the force profile. So what is the meaning of force profile? When two bodies collide, how does the force applied by them on each other changes with time? So I said in the very beginning, first the bodies come into contact, then they deform. At the time of maximum deformation, the force is maximum and then the bodies reform. So if we think of the force versus time graph, first the bodies get into contact and then the bodies deform. As the deformation increases, the force increases. At the time of maximum deformation, the force becomes maximum. And as the bodies start to reform, the force decreases and then again drops to 0 and then the bodies separate. So the force first increases, becomes maximum and then decreases and drops to 0. So this particular area gives you what? So what does the area under force time graph gives? The area under the force time graph gives you change in momentum. The area under the force time graph gives you impulse. Area under force time graph gives you integral f dt, which is nothing but impulse. So here the shaded area gives you nothing but impulse of deformation. The change in momentum of the bodies during the process of deformation. This is what the shaded area will give you. Similarly, the second shaded area is the area under the force time graph during the process of reformation. So this area gives you beta the impulse of reformation. So beta t is the time of maximum deformation. At the time of maximum deformation, the force is maximum. Now here you can say the areas of both deformation part and reformation part I have made equal. Why? Because here I am telling you the force profile of elastic collision. In elastic collision, the impulse of reformation, the area under the force time graph during the reformation part is same as the area under the force time graph for deformation part. So this symmetric graph is the graph for elastic collision. For inelastic collision, what does the graph look like? For inelastic collision, we know that E lies between 0 and 1. So E, which can also be written as impulse of reformation upon impulse of deformation. Since E is less than 1, we know that impulse of reformation is less than the impulse of deformation. As the impulse of reformation is less than the impulse of deformation, the area under the graph during the reformation part is less than the area under the graph during the deformation part. So for elastic collision, the graph looks something like this. The area under the graph during the reformation part is less than the area under the graph during the deformation part. Understand now, in elastic collision, so the bodies do not regain their complete shape. So the reformation is less than the deformation. So this is how the force profile looks for an inelastic collision. So here you can see impulse of deformation is greater than the impulse of reformation. So more area under the graph during the process of deformation and less area under the graph during the process of reformation. Here the darker area, the darker blue represents impulse of deformation and light blue represents the impulse of reformation. This area represents impulse of deformation and impulse of reformation. Let's move on. There are two special cases that has to be learned right now. The first special case. If two equal masses collide elastically head on, then what happens? If two equal masses collide elastically and head on, then what happens? So let's say we have got two masses m and they are moving with velocity u and v, and the collision is elastic. Coefficient of restitution is 1. So let's say after collision these two blocks have velocity u dash and v dash. From the equation of momentum conservation, we can write mu plus mv equals to mu dash plus mv dash. Cancelling out m in each term, we get that u plus v equals to u dash plus v dash. This is the first equation. We can make one more equation that will be the equation of coefficient of restitution. For this particular collision, we know that coefficient of restitution is 1. So coefficient of restitution is velocity of separation upon the velocity of approach. Velocity of separation will be written as v dash minus u dash, the rate at which the separation increases after the collision. Velocity of approach is the rate at which the separation decreases before the collision. So this velocity u is trying to decrease the separation. This velocity v is trying to increase the separation. So velocity of approach will be plus u minus v. So we will write from the equation of coefficient of restitution which is 1 in this case equals to velocity of separation upon velocity of approach. Velocity of separation will be v dash minus u dash, while the velocity of approach will be u minus v substituted. So you can break this u minus v on the left and you can write u minus v equals to v dash minus u dash. This is the second equation. Now on solving these two equations, we get that u dash comes out to be equal to v and v dash comes out to be equal to u. So we say that both the blocks exchange their velocity during the collision. When both the masses are equal and the collision is elastic. So if both the masses are equal and collision is elastic, then both the bodies exchange their velocity along the line of impact. If both the masses are equal and the collision is elastic, then both the bodies exchange their velocity along the line of impact. So for example, if tomorrow you see there is a block A of mass m, there is a block B again of mass m, A moves with a velocity of 3 meter per second and B moves with a velocity of 1 meter per second, and let's say coefficient of restitution is 1. Then after the collision, A will move with a velocity of 1 meter per second while B will move with a velocity of 3 meter per second, because they will exchange their velocity. Again, when both the masses are equal and the collision is elastic in nature. So now let's talk about the second special case. If one mass is very heavy compared to another, if let's say we are inside a bus and the bus is going with speed of 20 meter per second. We are inside a bus and bus is going with speed of 20 meter per second, and a small bug or a fly comes and hit the bus. Will there be any appreciable change in the velocity of bus? So if the bus is moving on a highway with speed of 20 meter per second and a bug comes and hits the bus, will the velocity of bus change? You'll say, sir, since bug applies some force, there will be teeny tiny change in the velocity. But I have seen bugs dying so many times on the windshield of the bus that the velocity of bus does not change appreciably. Why? Because, sir, the mass of bus is way bigger than the mass of the bug. Since the mass of the bus is way higher, it has a way higher inertia. So that's why there won't be any appreciable change in the velocity of the bus. So the same concept we are going to apply here. Let's say we have a block of mass m, capital M, moving towards right with a speed of 4 meter per second, and second block of mass small m moving towards left with speed of 2 meter per second. And the coefficient of restitution is 0.5. If m is way greater than small m, how will you find the velocity of both the blocks after the collision? So you will say, sir, this capital M is way heavier than this small m. Since capital M is way heavier than small m, I can say that during the collision there won't be any appreciable change in the velocity of capital M. So even after the collision, I can assume the velocity of capital M to be 4 meter per second towards right. For this small m, what will be the velocity? I don't know. So let's assume that the velocity of this m is v towards right after the collision. So if one mass is very heavy compared to other, its velocity remains nearly unchanged. Definitely, when the collision takes place, some force acts on the mass capital M. But as it is way heavy now, there is no appreciable change in the velocity. So you can assume the final velocity is to be 4 meter per second and v. Since you know that coefficient of restitution is 0.5, you can find out v. How? Beta, coefficient of restitution is nothing but velocity of separation upon the velocity of approach. So E equals to velocity of separation upon velocity of approach. Here you will write velocity of separation as v minus 4. So how do you know which minus what? Shan, what am I writing? Velocity of separation now. Velocity of separation is the rate at which separation increases after the collision. Look here, kids, this velocity v is trying to increase the separation, and this velocity of 4 meter per second is trying to decrease the separation. So we will say the rate of increase of separation after the collision will be plus v minus 4. So velocity of separation will be v minus 4. What will be the velocity of approach? Sir, the rate at which the separation decreases before the collision. This velocity of 4 meter per second is trying to decrease the separation. This velocity of 2 meter per second is also trying to decrease the separation. Both the velocities are trying to decrease the separation. So the velocity of approach will be 4 plus 2, that will be 6. So you will say coefficient of restitution 0.5 will be equals to velocity of separation, which is v minus 4 upon velocity of approach, that will be 4 plus 2. So this 4 plus 2 becomes 6. Bring this 6 to the left hand side, you get 0.5 into 6, that becomes 3. So you can write 3 equals to v minus 4, or v has to be equals to 7 meter per second. Let's do one more question of same type to understand the concept better. Question is, there is a block of mass capital M moving towards right with a speed of 20 meter per second, and a mass small m moving towards right with a speed of 10 meter per second. If capital M is greater than small m and coefficient of restitution is 0.5, determine the velocity of both the blocks after the collision. So you will again say, sir, as one mass is way greater than the other mass, we will say that there is no appreciable change in the velocity of this heavier mass. So we will say that this heavier mass will move nearly with the same velocity of 20 meter per second. As for this lighter mass, let's assume it goes with a velocity v. We can say that as capital M is greater than small m, its speed will remain nearly unchanged. So I have assumed that the speed of capital M after the collision is same as before the collision. Now coefficient of restitution equals to velocity of separation upon velocity of approach. Velocity of separation will be v minus 20. v minus 20. Think over it. v minus 20. While the velocity of approach will be 20 minus 10. 20 minus 10. So you will write coefficient of restitution 0.5 equals to v minus 20 upon 20 minus 10, which is 10. Bring this 10 up. So you get 0.5 into 10. 0.5 into 10 becomes 5. So you get v minus 20 equals to 5, or v comes out to be 25 meter per second. So just remember, if one mass is way heavier than the other mass, then assume that this heavier mass moves with nearly the same velocity after the collision. And the questions are easy. So the next question, there is a ball which is dropped from a height h. If a ball is released from a height h and coefficient of restitution is e, determine the height attained by the ball after the collision. To how much height above the ground the ball will go back up after the collision. This is the question. Now, visualize the case just before collision. Just before collision with ground, the ball will have some downward velocity. Let's call it v. And this velocity will be equals to root 2gh. Sir, how do you know? Apply the third equation of motion, v square minus 0 square equals to 2gh. So v comes out to be equals to root 2gh. Or better simply to half mv square equals to mgh, you will get that v has to be equals to root 2gh. And let's say after collision, this ball bounces back up with a speed v dash. We have learned that coefficient of restitution is velocity of separation upon velocity of approach, given that velocity of separation and velocity of approach are taken along the line of impact. For this particular collision with ground, the line of impact will be vertical line. So the ball has entire velocity vertically downward, root 2gh before collision and v dash upward after the collision. So you will say E equals to v dash upon v, or v dash equals to ev. That can be written as E times root 2gh. So just after the collision, if the ball hits with a speed v, we know that it will go back up with a speed ev. Sir, how do you know? It's okay. Beta, so easy. E equals to velocity of separation upon velocity of approach. If the velocity of approach is v and coefficient of restitution is e, then the velocity of separation will be na ev. So just after collision, the ball will have an upward velocity ev. Now we know that when we project a ball upward with a speed u, how much height does the ball attain? The ball attains a height equals to u square by 2g. So when projected up with a speed u, the ball goes up to a height u square by 2g. Here, after collision with ground, the ball has an upward velocity ev. So the ball will go up to a height, say h dash, which will be equals to e square v square by 2g. In place of u, substitute ev. So you get e square v square by 2g. Now, in place of v, if I substitute root 2gh, what will I get? E square into root 2gh square, that is 2gh by 2g, and this will be equal to h dash. So cancelling out 2g, you get h dash equals to e square h. So if you drop a ball on a surface for which the coefficient of restitution of collision is e from a height h, then the ball will bounce back to a height e square h. This is something that you should remember. Now let's see one more question based on this. Question is, a ball is dropped from certain height. If the ball loses 75% of its energy during the collision, determine the coefficient of restitution. If the ball loses 75% of its energy during the collision, determine the coefficient of restitution. Now this question looks like a tough question. You will have to do a lot of calculation. Maha's easy question. So let's do it. You will say, if the ball loses 75% of energy, during the collision, it means that it retains 25% of the energy. Retaining 25% of energy means retaining 1/4 of the energy. Now with 1/4 of the total energy, it will go to only 1/4 the total height. So if you have dropped the ball from a height h, it will bounce back to a height h by 4. So how do you know? See, you know that gravitational potential energy equals to mgh. Gravitational potential energy is directly proportional to height. So if the entire total energy becomes 1/4, it means that the final maximum height attained will also be 1/4. Na? So energy retained is 25%. So the final potential energy will be 1/4. As the final potential energy will be 1/4, so the final height will be 1/4. Once you know that final height is 1/4 of initial height, game over. You will say, sir, I have just learned that the height after collision, h dash, has to be equals to e square h. And I know that the final height h dash is h by 4. So I can write h by 4 equals to e square h, or e square equals to 1 by 4, or e will be equals to 1 by 2. So simple. Let's do one more question. Everything same, just one small change in data. If I say that if the ball loses 64% of the energy during the collision, determine the coefficient of restitution. You will say, okay, if the ball loses 64%, then the ball retains 36%. If the ball retains 36%, then the final potential energy will be 0.36 times original. If the final potential energy will be 0.36 times original, the final height attained will be 0.36 times original. If the final height attained is 0.36 times original, I can write h dash 0.36 h equals to e square into h. Cancel out h, so you get e square equals to 0.36 or beta e equals to 0.6. So the coefficient of restitution for this particular collision will be 0.6. Okay, let's move on. The question is, there is a ball. The ball has got horizontal velocity of 3 meter per second and vertically downward velocity of 8 meter per second. The coefficient of restitution for the collision of ball with the ground is 0.5. Question is, in a gravity-free region, a ball moving with the velocities as shown collide with a surface. Determine the velocities horizontal and vertical of the ball after the collision. So this particular example has been taken to make you understand the concept that E equals to V sap upon V ap. Here the velocity of separation and approach have to be taken along the line of impact. When this ball goes and collides with the ground, in which direction the forces will act? Sir, the forces will act along the line of impact, and the line of impact will be the line of common normal. So the forces will act in the vertical direction. So as the forces act during collision in the vertical direction, there will be no change in the horizontal velocity. Two mutually perpendicular directions are mutually independent. If the force acts in vertical direction, only the vertical velocity will change. So even after collision, I can say with 100% guarantee the horizontal velocity will be 3 meter per second. And let's assume the vertical velocity to be upwards v. So we know that coefficient of restitution is velocity of separation upon velocity of approach, where velocity of separation and velocity of approach is taken along the line of impact. Now assume that after collision, the ball has a vertically upward velocity v and the horizontal velocity of 3. Because the line of impact is vertical, so the horizontal velocity won't change. Now question is, what will you write velocity of separation and what will you write velocity of approach? See beta, the ball comes and hits the ground. Velocity of separation and velocity of approach are the velocities along the line of impact. In this particular case, the line of impact is vertical. So velocity of separation and velocity of approach are the velocities after collision and before collision in the vertical direction, because the line of impact is vertical. So you will say velocity of separation will be v, while the velocity of approach will be 8, not 3. 3 is not in the direction of line of impact, 8 is, and similarly v is. So you will say coefficient of restitution 0.5 equals to velocity of separation upon velocity of approach, that will be v by 8. So v comes out to be equals to 4. Once you know that after collision horizontal velocity is 3, vertical velocity is 4, so the net velocity will be equals to under root of 3 square plus 4 square. So the net velocity will be 5 meter per second. Okay, let's do one more example based on the same concept. Question is, there is a ball given a velocity v in a gravity free region such that its velocity makes an angle theta with the horizontal. If the coefficient of restitution for the collision is e, you need to find phi, the angle made by its velocity vector with the horizontal after the collision. So if the region is gravity free, find the angle phi. This is the question. So you will say one can break down the velocity of the ball before collision into component. Horizontal component will be v cos theta. Vertically downward component will be v sin theta. Now you have to think and tell, during collision which component won't change? So during collision the forces will act along the line of impact. In this case the line of impact will be this vertical line. So the vertical velocity will change, but the horizontal velocity won't change. So the horizontal velocity even after the collision has to be v cos theta, and sir, let's say the vertical velocity is v dash. So we will say, assume the velocities after collision horizontal to be v cos theta and the vertical velocity to be v dash. We can say coefficient of restitution equals to velocity of separation upon velocity of approach. Velocity of separation v dash upon velocity of approach. You should take the velocity of approach along the line of impact v sin theta. So after collision, the vertical velocity v dash comes out to be ev sine theta, which was already directly written. So after collision, the vertical velocity will be ev sine theta, horizontal velocity will be v cos theta, and let's say the net velocity makes some angle phi. So you will say if the net velocity makes some angle phi, where the vertical component is ev sine theta and the horizontal component is v cos theta, then you can say tan phi equals to ev sine theta upon v cos theta. Better you can cancel out v and write this sine theta by cos theta as tan theta. So you get tan phi equals to e tan theta. So easy. Now let's do one more example where I will use this concept. If the vertical velocity before impact is downward v sine theta, then after impact it is vertically upward e times v sine theta. So let's see. Question is, determine theta dash, t dash, h dash, r dash in terms of theta t h r. So there is a ball projected with speed v at some angle theta with the horizontal. You have to tell after the first collision with the ground at what angle the ball will move. If you call that angle theta dash, how will you write theta dash in terms of theta? If the time of flight of this second parabolic path is t dash, how will you write t dash in terms of t? If the maximum height attained is h dash, how will you write h dash in terms of h? And if the range for the second projectile is r dash, how will you write r dash in terms of r? It's an easy question and we have already done most of the part. So you will say, think of this ball's velocity just before collision and just after collision. So just before collision, this ball will have horizontal velocity v cos theta and vertically downward velocity v sin theta. At the time of collision, line of impact is vertical. So sir, the horizontal velocity won't change. And the vertical velocity after collision will be upward, ev sin theta. So just after collision, think of the velocity. So just after collision, vertically upward velocity ev sin theta and horizontal velocity v cos theta. So you can say the net velocity, if it makes some angle theta dash, then you can say tan theta dash equals to ev sin theta by v cos theta. Cancelling out v and v, you write tan theta dash equals to e tan theta. Okay. So tan theta dash equals to ev sin theta by v cos theta. So tan theta dash equals to e tan theta. Simple thing. Now the next thing we need to find is time of flight. But the time of flight depends upon horizontal velocity, vertical velocity, both none. Time of flight depends upon vertical velocity. The time of flight is given by 2 times v vertical by g. If you think of the vertical velocity for the first parabolic path, that is v sin theta. If you think of the vertical velocity for the second parabolic path, after the first collision, the vertical velocity becomes ev sin theta. Beta, if the vertical velocity becomes e times, if the vertical velocity becomes e times and time of flight is directly proportional to vertical velocity, then time of flight will also become e times. So you can say time of flight is 2v vertical by g. The second time of flight will be equals to 2 times e times of v vertical by g. So the second time of flight t dash can be written as, if you think of just this part, 2v vertical by g, this is the original time of flight. So the time of flight for second journey equals to e times the first time of flight, et. Second, what will be the maximum height attained, h dash? Sir, we have already done this. H dash has to be equals to e square h. You always say two mutually perpendicular direction are mutually independent. So if dropped from a height h, it goes back to a height e square h. It doesn't matter if you add up a horizontal velocity. Good thought, but let's do it again. We know that the maximum height attained is v vertical square by 2g. Now maximum height attained is proportional to v vertical square. After the first collision, the vertical velocity becomes e times. So you will say the new maximum height attained, h dash, will be equals to e times v vertical whole square by 2g. So you get an extra term of e square. That's why the maximum height attained after the first collision equals to e square times the maximum height attained in the first parabolic path. So easy. Now the last one left out, what happens to range? So you will say, sir, range depends upon horizontal velocity, vertical velocity, both none. Range depends upon horizontal velocity, vertical velocity, both of them or none of them. The range depends upon both of them. Range is given as the horizontal velocity into the time of flight, and time of flight can be written as 2 times v vertical by g. So the range depends upon both horizontal velocity as well as vertical velocity. During the entire motion, the horizontal velocity is constant because even during collision, the force is in vertical direction. So there is no change in horizontal velocity. That remains v cos theta. But after the first collision, sir, the vertical velocity becomes e times. So the time of flight becomes e times. Since the time of flight becomes e times, the range will become e times. So you can say, let's say the new range is r dash. That will be equals to the same horizontal velocity, but the vertical velocity becomes e times. So you get an extra term of e outside. So you say that the range for the second projectile motion equals to e times the original range. So you will say the range after the first collision will be equals to e times the first range. The maximum height attained will be equals to e square h. The time of flight will be et. Okay, remember these simple things. Moving on to the last heading, which is oblique collision. So what is oblique collision? All the examples I was dealing with till now were of that of head-on collision. In oblique collision, when you have got two bodies, their line of impact is not along their velocities. So when the bodies collide, the line of impact makes some angle with their velocity. So these type of collisions are called oblique collisions. Now the question is how to solve a question if it comes on the oblique collision. Beta, all the oblique collision questions are lengthy to solve. They can't be solved within a time frame of 2 to 3 minutes. That's why they become very improbable to be asked in the NEET examination. That's why I'm not at all taking any example here of oblique collision, and I will ask you not to waste your time on this. But there is one important case given in NCERT that you should know about, that I will teach up next after this page. But in oblique collision also, if luck by chance the question comes, what to do? The same thing. We can make the equation of coefficient of restitution along the line of impact. So you will have to write the velocity component along the line of impact before collision and after collision. And then you will have to make the equation of coefficient of restitution as coefficient of restitution equals to velocity of separation upon velocity of approach, given that you take both the velocity of separation and velocity of approach along the line of impact. This is the first thing. Second, beta, you can also make the equation of momentum conservation in horizontal direction, in vertical direction, or along the line of impact and perpendicular to line of impact. Remember that the velocity of both the bodies perpendicular to line of impact will remain the same, because during the collision the forces will act along the line of impact. So the velocity of both the bodies perpendicular to the line of impact will remain same even after the collision. This is the simple thing that you should know. Now let's focus on the important case given in NCERT. So the important case given in NCERT, and this important case comes with many writers. So if we have two equal masses, so the first rider, both the masses should be equal, that collide elastically. Second rider, masses should be equal and they should collide elastically and obliquely. This means that the velocity should be not along the line of impact, with one of the mass at rest before collision. So I am discussing a case with four riders. First, both the masses should be equal, collision should be elastic, collision should be oblique, as well as one of the mass should be at rest before the collision. This particular case is important because it is given in NCERT and it is used on the pool table, billiard table, snooker table, you say it. So let's say one of the mass is at rest and another mass moves with a velocity v. As the collision is elastic, listen to this line carefully, as the collision is elastic and masses are same, equal, the velocity exchange along the line of impact. I taught you guys, if two masses are equal and collision is elastic, then they change their velocity along the line of impact, right? This is what we learned. But sir, that was for head-on collision, right? Now this is oblique. Still, if the masses are same and collision is elastic, the bodies will exchange their velocities along the line of impact. So let's say this is the line of impact and this is the picture just before the collision. Let's call the two masses mass 1, mass 2, mass 1, mass 2. Since the masses are equal and collision is elastic, they will exchange their velocity along the line of impact. If let's say the line of impact makes an angle theta with the velocity of 1, then you can break down the velocity of 1 into components, v sine theta and v cos theta. I ask you, what is the velocity of 1 along the line of impact just before the collision? So you will say, sir, the velocity of 1 along the line of impact just before collision is v cos theta. What is the velocity of 2 along the line of impact just before collision? You will say, sir, 2 is not moving. It has got no velocity. How will it have velocity along the line of impact? So there is no velocity of 2 along the line of impact just before collision. But the velocity of 1 along the line of impact just before collision is v cos theta, and both of them are going to exchange their velocity along the line of impact. This means that the velocity of 1 along the line of impact after the collision will be 0, and 2 will have a velocity v cos theta. So, as no change in the velocity in direction perpendicular to line of impact. Sir, how do you know there will be no change in velocity perpendicular to line of impact? Sir, the forces act along the line of impact. So there will be no change in velocity perpendicular to the line of impact. So the velocity of 1 perpendicular to the line of impact will remain v sine theta even after the collision. Now just after collision, the velocities will get exchanged along the line of impact. So the velocities will be, this will have the same velocity v sine theta, while the second mass will start moving with a velocity v cos theta. Now what are you trying to explain here, sir? What I am trying to explain here is that if two masses are equal, they collide elastically and obliquely, and given that one of the mass is at rest before collision, then both the masses move perpendicular to each other after the collision. So both the bodies move perpendicular to each other after the collision. You said that this case is important. Why? If you play pool or snooker or billiard, there is a white ball called the cue ball, and with this white ball we hit the other balls. All the balls have same mass, so mass mm. The ball you are hitting is at rest, and usually we take cut shots, so we do not hit center to center, we hit it obliquely. And if the ball is not spinning, it goes straight and hit. Since the balls are made up of marble, the coefficient of restitution is nearly 1. That's why the cue ball and the ball you are hitting usually move perpendicular to each other after the collision. Given that this ball has been given only velocity and no omega, so they move perpendicular to each other nearly after the collision. So that's all in collision. See you guys in the next hour, where we will talk about center of mass. Bye bye. So that's all for now. See you guys in the next hour.